Hello students. So today we are going to continue the chapter Combustion and Flame, and in this chapter, in this particular video, we are going to discuss about the topic flame. So flame, so what is flame basically? So flame is the visible and vaporized part of a fire. No doubt most of you have seen this kind of flame is coming out of the fire when we are going to burn specific substances like wood, like petrol, like kerosene. So you must have seen even candle also. So you must have seen this kind of flame is coming out of the fire. So what is this flame? I have already told you this is the visible and vaporized part of a fire. And remember, this flame is going to produce when a substance which is going to vaporize. So when the substance, only those substances which can vaporize can burn with a flame. So the substances like kerosene, wax, wood, petrol, these are the substances which generally vaporize first, and then these vapors are going to burn in form of flame. Whereas there are some other substances like charcoal which do not produce any kind of flame. Why? Because these substances are not going to vaporize. So no vapors are there, so no vapors are going to burn, and there will be no flame that is going to produce. But these charcoal type material or substances are going to glow like this, as you can see in this picture. So these are the charcoal which are burning with a glow without any flame. So that is the all about flame. Now moving ahead, so flame can be of two color, although the color of flame can be more than two, but generally it is blue flame, that is non-luminous flame. So blue color flame is produced when there is sufficient supply of oxygen to burn the substances completely. So that means when there is complete combustion. We have already taken this complete combustion topic in the previous video. So when there is complete combustion, the flame that is going to produce will be of blue color. Like in the case of this LPG stove, you can see the blue color flame is coming out. So why this blue color flame is coming out? That means this is the indication that complete combustion of LPG is taking place. That means there is a full supply of oxygen, sufficient supply of oxygen to combust this LPG. Similarly, there is other type of flame that is known as yellow flame, which is yellow in color, and it is also known as luminous flame. Remember, this yellow flame is produced when there is insufficient supply of oxygen. When oxygen supply is not sufficient, that means incomplete combustion is there, then this yellow flame will going to produce. And normally in the candle flame, you have seen that yellow color flame is coming out. So this yellow flame, remember this thing, this yellow flame is because of the glowing of unburned carbon atom. So this carbon atom is, you know very well, the fuel which we are going to use, like in the case of LPG or wax in the case of candle. So both are having hydrogen and carbon, that is hydrocarbon. So when we are going to combust this fuel, that is wax in this case, so the hydrogen and carbon part of the hydrocarbon will split. Hydrogen will convert into the water, and carbon, specifically the unburned part of the carbon, unburned carbon atoms, they are not going to burn basically, but they are going to glow in the high temperature. So this glowing of the carbon atom is going to produce the yellow color, yellow flame, like this. We will see this video in the coming slides. Now again, if we talk about the flame types, so let us see this example of Bunsen burner. So these are the Bunsen burner. So here, if you are going to do this activity in the laboratory, so we are going to perform it. So here you can see this is the Bunsen burner, in which this air vent is closed, whereas in this case the air vent is open. So when we are going to, so in both the cases, what you will going to observe, so when air vent is, this hole is closed, so due to which the oxygen supply is affected, and it will not get sufficient oxygen for the burning. So there will be incomplete combustion. So the flame that is going to produce out will be yellow in color. So this yellow flame is. But when this air vent or air hole is open, so it will get sufficient amount of oxygen, and the fuel will burn completely to produce blue color flame like this. So this is how the color of flame is affected because of the supply of oxygen or the combustion processes like incomplete combustion or complete combustion. So remember, whenever there is complete combustion, that means blue flame is going to produce, or blue flame is producing out, that means complete combustion is taking place. Now let me show you one video file also. It is going to tell you why the flame of candle is yellow in color during incomplete combustion. So let us watch this small slide. So here you can see hydrocarbon is going up through this hose pipe, and when it is burning, remember this is an example of Bunsen burner in which no air supply is present. This vent is closed. So when this hydrocarbon is going to burn, so what will happen? The hydrogen part will convert into the water molecule, whereas carbon, some part of the carbon is going to convert into the CO2, and some part of the carbon is going to glow like this. This is the unburned carbon atom which is going to glow to produce the yellow color. So you can see this yellow color is coming out. So this is how a yellow flame is going to produce when there is incomplete combustion. Now moving ahead about the detailed structure of the flame which is coming out from the candle. So you have seen that if we are going to burn the candle, so this flame is going to produce out. So there are different zone of candle flame, as you can see in this picture also. So you can see the outer flame zone is basically known as non-luminous zone, and second zone is basically known as luminous zone, which is yellow in color, and this outermost zone is basically light blue in color. Then in the center there is a zone that is known as dark zone, which is innermost zone, and just above the wick, this is the cotton thread you can see. So this is wick basically, which is having the blue zone. Now if we are going to study these zones in detail, so non-luminous zone is also known as the zone of complete combustion. Why it is the complete combustion zone? Because it is getting full supply of oxygen from the surrounding. So because of the availability of oxygen, this hydrocarbon, that is wax, is completely oxidized or completely combust. So complete combustion is taking place. And remember, the temperature of this zone, flame zone, is very high. It is around 1400 degrees Celsius. Remember this thing. So this is the outermost zone of the flame, which is at high temperature. Second zone is the middle zone. Sometimes it is called as middle zone, as you can see in this picture, and it is also known as luminous zone. So this is the zone of incomplete combustion. Combustion is taking place but incomplete. And yes, it is moderately hot, not that much hot, and the temperature is around 800 to 1000 degrees Celsius. And yes, it is the middle zone of the flame. Third one is the dark zone, which is present in the center of this flame, which is the innermost zone, and it is the zone of no combustion. As no combustion is taking place, so it is the zone of no combustion, and the hydrocarbon, that means the wax which is coming out through this wick, is basically present in the vapor form in this particular zone. So no combustion is taking place in this dark zone. And the last one is the blue zone. Although we divide this flame into three main zones, blue zone is basically the small region. It is present at the base of wick. As you can see, this is the wick, I have already told you. So blue zone, so it is due to the incomplete combustion of fuel. Again, no air is present basically. So here most of the carbon monoxide gas is going to be produced at this particular point in large amount. So this is blue zone basically. So this is all about the structure of the candle flame. Now if we can study, this is the activity which is given in your syllabus. So this is the activity to study about the structure of candle flame. So here you can see in this picture, so this is the dark zone. This is the experiment to conclude about the dark zone. This is the experimental setup to conclude about the luminous zone, and this is for the non-luminous zone. So what we can do, so what we have to do is we have to enlight the candle, and yes, we have to place it in that area where no air is present, no wind is present, so that flame should be should be straight enough. That means should not flicker basically. So what we have to do is, to do this activity, we have to take this narrow glass tube first of all, and we have to hold this with the help of tongs. This is the metallic tong, as you can see. And what we have to do is, we have to place the one end of this narrow glass tube in the dark zone of a flame, as you can see in this picture. And on to the other hand, what we have to do, we have to bring the lightened mastic near to the other end, and what we will see is the flame, this mastic will keep on burning. I mean, this narrow end part will start burning. Why it will do so? Because the this dark zone is having, yes, this dark zone is having the uh, vapors of the hydrocarbon or the wax. So these vapors are going to come through this particular glass tube to this end, and these vapor of the wax is going to burn at this particular end. So this is going to show us that the dark zone is consist of hydrocarbons in vapor form. So this is about the dark zone. Similarly, what we have to do, so we in the next setup, what we have to do is, we have to take a glass slide. As you can see, this is the rectangular glass slide, and we have to place this glass slide inside the flame, in such a way that we are going to put it onto the luminous zone of the flame. So what we will see after some time, that black color of carbon particle will deposit onto this particular slide. So this is the deposition of black unburnt carbon particle. So this is going to show us that yes, this luminous zone, that is the second zone or the middle zone, is consist of unburnt carbon atom. Similarly, this is the this is the copper wire which we have hold with the help of tong, and we have to place this copper wire, we have to touch it at the tip of the flame, where we are getting the non-luminous zone. So at this particular tip, when we are going to put this wire, so this whole wire will become hot, red hot even. So why it is so? Because this outer zone of the flame is having maximum temperature, and it is the non-luminous zone which is not visible also. And yes, it is going to give us the maximum temperature, and this copper wire will also become hot because of the high temperature. So this is how we can get the idea of the structure of flame of candle, like this. Okay, now moving ahead about the next topic. So this is the topic of calorific value of a fuel. Remember, calorific value of a fuel is a kind of parameter which give us idea about the quality of fuel. So what is this calorific value? So calorific value is the amount of heat that is basically produced when we are going to burn at least 1 kilogram of fuel. So when we are going to burn 1 kilogram of fuel, so the amount of heat liberated, so that is basically known as the calorific value. Remember, when we are going to burn the fuel, it should be complete combustion in the presence of sufficient supply of oxygen. So as per the definition, calorific value of a fuel can be defined as the amount of heat liberated when 1 kilogram of the fuel is completely burned into sufficient supply of oxygen. So higher the calorific value, better is the fuel. Remember this thing, more is the calorific value, better is the fuel. So the SI unit, the standard SI unit of calorific value is joule per kilogram. Remember, joule is the unit of energy. So when we are going to burn fuel, that is 1 kilogram, so this much amount of energy is going to release. So maximum joule is going to produce out, that means maximum calorific value is there. So this is the SI unit, that is joule per kilogram. Sometimes it is also represented in the form of kilojoule per kilogram, and sometimes it is also represented in form of megajoule per kilogram, like this. Okay, so if you can see the examples of some calorific value, like methane, you can see. So methane is a gas which is having the calorific value of around 55,000 kilojoule per kilogram. Similarly, we are having kerosene, petrol, diesel. So these are the petroleum products which is having the calorific value about 45,000 kilojoule per kilogram. Remember, kerosene, petrol, diesel are having same calorific value. Similarly, we are having LPG gas which we use in our kitchens also. So here you can see the calorific value of LPG is 50,000 kilojoule per kilogram. That is very, very good. And yes, there are some fuel like normally used in the rural areas like cow dung cake. So that is having the calorific value around 7,000 kilojoule per kilogram. That is very low. So that means the calorific value of these fuels is going to tell us about the quality of fuel. So more is the calorific value, better is the fuel, remember. So this is basically one of the characteristic of a good fuel, but there are some other characteristics also. So if you are going to judge about the quality fuel, which fuel is good, so you should notice following characteristics. So a fuel should be a low ignition temperature. So whatever fuel we are going to be are using, so that should have low ignition temperature. So this is the first characteristic. So a good fuel will be having low ignition temperature. Like LPG we are using in our kitchen, so it is having low ignition temperature, sorry. So that means they are going to burn very easily, whereas the fuels like wood or cow dung cake, these are having high ignition temperature. That means it is not going to burn easily. So that means we have to prefer those type of fuels which is having low ignition temperature. Similarly, we should have the fuel which is having high calorific value. That means more amount of heat is going to be produced with the burning of 1 kilogram of that fuel. So high calorific value is going to give us the better quality fuel. So LPG is again coming in that standard also. Similarly, moderate rate of combustion. That means we should not use that kind of fuel which burn instantly, suddenly. But in fact, we should use that type of fuel which having moderate rate of combustion. Should not be very high rate of combustion. Otherwise, it will burn quickly, and we cannot grab or we cannot collect the heat properly. Similarly, it should not be that much slow that it is going to take more time. So we should select moderate rate of combustion. So that is basically rate of combustion. It should be moderate. And the fuel should be safe to store, safe to handle, safe to transport. Otherwise, it is very difficult to to transport this fuel from one place to another. So that is why it should be easy to handle, easy to store, and safe also. And yes, the fuel which we are using should not produce any kind of residue in the form of ash. As we have seen, if you are going to burn the wood, or if you are going to burn the charcoal, if you are going to burn the cow dung, normally we use this method in our rural areas. So they are going to produce lot amount of ashes, lot amount of residue. So that is again against the quality of the fuel. So we should use fuel which is not going to give much residue, like in the case of LPG. So LPG is basically most usable and most better quality fuel, I would say. Similarly, it should be cheap enough and easily available. Otherwise, there is no use of fuel. Okay, the best example I have taken is the LPG. Otherwise, normally natural gas. Nowadays, natural gas is very famous. So this is again used as a fuel even in the vehicles also. So natural gas is also a good kind of fuel. Now, if we talk about the types of fuel, so fuels on the basis of their physical state can be solid, can be liquid, can be gases. Like solid fuels are like coal, wood, cow dung cake. These are solid in form. So these are solid fuels. Liquid fuels are petrol, kerosene. Even LPG is also liquefied petroleum gas. It is present in liquid state, and when we release the valve, so it convert into the gaseous form. So generally, it is liquid fuel. And yes, gaseous fuels are like natural gas and biogas, methane gas. So these are the these are the gaseous fuel. Now moving on to the topic of impact. So when we are going to use these kind of fuels, in fact we are using different type of fuels like fossil fuels, coal burning, wood burning. We are using this kind of fuels. So if you are going to burn the fuels, so there is the effect of these burning onto our environment also, because when we are burning the fuel, it is going to produce lot amount of pollutants in the form of smoke, in the form of dust particles. So many pollutants, even gases also are going to come out when we are burning this fuel. So these are the common problems or impacts which is basically caused due to burning of the fuel onto the environment. So release of ash, unburned particle, SPM, that is the suspended particle material. So these are going to come out when we are going to burn the fuel. And yes, CO2 kind of gases are also going to release out, which is again causing global warming by greenhouse effect. And yes, sulfur dioxide, oxide of nitrogen, these are also coming out when we are using these type of fuels like diesel, petrol in our vehicles or in industry. So these oxides are coming out in our atmosphere, and yes, because of this, you know very well, acid rain problem is coming out, because oxides of nitrogen and sulfur are going to mix with the water present in our atmosphere to form the acid rain. And yes, carbon monoxide gas, incomplete combustion is there, then carbon monoxide gas will produce, and which can cause death of the person due to suffocation. And yes, there are some lead compound also present in our fuel, which is going to release in our atmosphere. And obviously lead is heavy metal. It is a kind of metal which is heavy metal, and because its density is high, and they are affecting our kidney function also, and they are affecting our brain function also, lead basically. Now we are going to take this topic, these points one by one. So I have told you that when we are going to burn fuel, so they are going to release ash, unburned particle of carbon, and suspended particle like this. So obviously when this smoke or this ash or this suspended particle matters are going to come in our atmosphere, so obviously they are going to affect our respiratory system, because we are going to breathe these particles inside our lung. And when these particles are going to inside our lung, so they are going to cause many respiratory diseases like asthma, like cancer. So many diseases will come because of this emission. Similarly, second point was related with the carbon dioxide, and I have told you carbon dioxide is basically greenhouse gas, remember. So when this solar radiation which is coming from the sun reaches our earth, and after our striking our earth surface, when this radiation is going back, so instead of going directly to the space, these radiation are basically trapped with the carbon dioxide greenhouse gas. So carbon dioxide is greenhouse gas, and this carbon dioxide does not allow these radiations to go into the space, but because of this carbon dioxide, these warm radiation or infrared radiation split and spread into our atmosphere. And because of this only, the atmosphere is the temperature of atmosphere is increasing. So this is what global warming is. And because of this global warming, you know the consequences, what is going on. The best example of this is, the best impact is the melting of glaciers. So you can see this is the impact, this is the major impact of the global warming. So you can see this, this was the earlier picture, and in which you can see icebergs are there. And later on, after the global warming, what you can see is the ice is melting, the whole glacier is melted away because of global warming. So this is the kind of impact can be caused by the burning of fuel onto the environment. Similarly, I have told you about the acid rain. So acid rains are going to produce when sulfur dioxide or nitrogen dioxide gases are released in atmosphere, and when these gases are combined with water, so they are going to form the acid rain. Like sulfuric acid will form, nitric acid will form, and these acid will come down in the form of rain, that is known as acid rain. And when these acid rains are going to fall upon the monuments, like in this picture you can see, so this is the picture of Germany. So this is the picture, as you can see, the left side picture was taken in 1908, and this picture was taken in 1968. After 60 years, so this deterioration was occurred because of the acid rain effect. Similarly, acid rains are going to affect our ponds or lake also. You can see lots of fishes, aquatic organisms are dying because of the rise in acidity of this water. Because of acidic rain, this acidity of water increase, and because of this fishes or aquatic life is disturbed basically. So these are the impact of what we can say, various type of pollutant which we are going to release in the environment because of this burning of fuel. Similarly, I have told you about the carbon monoxide which is going to release in atmosphere because of incomplete combustion. And yes, lead compounds is also going to release when we are through vehicle exhaust, and they are also very highly toxic. They are causing the damage to our brain and kidney also. So this is all about this topic of combustion and flame. So just attempt the questions, and any doubt we will take in the doubt classes.